Okay, imaginary complex numbers. Okay, so here's the deal. All along, you've been taught this. You can't square root negative numbers. Until today, we're going to call them imaginary numbers. Okay? So that's why it's called an I. It's called an imaginary number.
Why are we imagining stuff?
Okay, so officially, today I can finally tell you that math joke, it used to be on my wall, but what does that say in a sentence?
Well, square root of negative 1 is I.
I.
Times 8.
8.
I ate 3 pie.
Some pie.
Oh, wait, no, that's like wrong. 3 pie.
I ate some pie.
I ate some pie.
Good.
There, now you got the joke. What were you calling it?
I don't know.
Okay, so here's the deal. Example 1, simplifying. In this one, you can only do the real numbers with the real numbers, imaginary with the imaginary, so it will be 11 real numbers and adding to 9 imaginary numbers. Right? Am I good? I can combine those together. They're like terms, and these are like terms. Just a like term situation. Okay, brackets. Do brackets change anything in the front? No. So 9 plus 4i. Do these brackets change anything about the binomial here? Yes. What do? Distribute the front of the bracket there. So this would really be an add 4. Oh, and an add 5i. So once you collect like terms, you get 13 and an add 9i. Okay? And I think that just the normal general rule is to write the real part first and then followed by the imaginary part. Okay? Okay, versus that. Okay? Just writing the real plus the imaginary. Okay, so 6 times. What is the value for I? The square root of negative 1. And then we're going to square it. So what happens to you when you square a square root?
It's just negative 1.
They cancel, and it's just negative 1. So this answer would be negative 6.
Is I always negative 1?
I squared is always negative 1, because I is the square root of negative 1.
I did not get a single question.
I is the square root of negative 1. So if I do I squared, the square root of negative 1 squared is always negative 1. Okay. Okay, distribute that. So 2i times 5i will make 10i squared and plus 14i.
Oh, I see.
But what did we just learn about I squared?
It's negative 1.
It's negative 1, which will make this negative 10 plus 14i. Okay? Okay, tell me what to do when you square binomials. FOIL. So if you square a binomial, you better do all 4 components, which will make 4i squareds. Can we double this up here with a negative 6i, negative 6i, OI? So negative 12i's plus 9. What did you just learn about I squared? It's -1. So this is actually the number -4. So now I can put it together with the 9. So that will make 5 minus 12i. Okay? An I is simple. You can't do anything more with an I. An I is the lowest you can always go. Okay. I to the 80. I am going to always revert back to my I squareds. And what kind of math would I do to create an exponent of 80 in this situation? I would put a 40 up there. Do you guys like that? Does that make I to the 80?
Yeah.
Yeah. Okay, remembering your exponent rules. An exponent to an exponent, you multiply, right? Okay, what is I squared? -1. What happens in math if you go -1 times -1 times -1 times -1? It would equal +1. Repeat.
An even number.
An even amount, yeah. Okay.
What is this unit circle?
It's like this, there's like 2 things in this unit, and this is one of them, and then that other stuff. Okay, I squared. Okay, I'm going to tell you it's not going to work to 19, right? 2 times something. You're not going to get to 19. What could we get to?
18.
18. So how would I get to 18? 2 times 9. So that's 18. So I still need one more. So do we like that? Is that going to make 19 repetitions?
Yeah.
Okay. Now, what's I squared?
-1.
-1 repeated 9 times. -1 getting -1 times -1 9 times is -1. And then an I. And you got to leave the I, right? If you have an I, you can't go anymore.
Do we have to make the I fancy, or is it just?
Have to make it fancy.
Seriously? Okay.
You guys were taught cursive writing though, right?
Yeah. In like grade 3. I can't do a capital G.
Okay. We're not going to get to 21 with I squareds. So if we can't get to 21, let's get to 20. So then that would be a 10. So I'm at 20 of those I's. So I still need one more.
Could you like go up 1 and then subtract? No?
You like divide?
Oh, yeah.
No, thank you.
See, my handwriting is always
Okay. And then you'd have to turn the divide into a negative exponent and then move it back up.
It's just stupid.
Okay, so I'm going to turn the I squared into a -1, repeat it 10 times, and now I have to think about math. -1 repeated 10 times is +1, and then 1 I. That's my answer. Okay, I cubed, so I'm going to get I squareds. And then, well, I just have to do that once because I can't do it more than that, right? But then I need another I, right? So that's the most I can do with that. And then what's I squared? -1. And then I. Okay. We need to talk about this. What's the difference? No, I'm going to do to the 4th. What's the difference in me asking you these 2 questions?
The negatives included.
Include. This is like this kind of math. Right?
Yep.
This is this. Do you see a difference?
Yep.
This is repeat 2 a bunch of times and then times it by -1. This is repeat -2 a bunch of times. Okay, good? So, are we repeating that negative sign? Yes. So what if I repeat that -1 15 times? It would be -1.
But it's just I.
And now I'm also repeating I 15 times. I'm repeating the number in the front. Okay, should I do another example? What is this? What is the answer to this?
6A cubed. No, 8.
8a cubed. Got it? Because you repeat 2, 2, 2. You repeat that, and then you also repeat the a. Okay, so you treat it like what's the coefficient repeated value, what's the variable part repeated. Okay, good. Now, what are we going to do with I-15? Let's do some work with I-15. I squareds. I can't get to 15, so I'm going to work to 14. So that's a 7. So 14, 15. I squared, that's -1. What's -1 repeated 7 times? -1. -1 times that original coefficient, -1, +1. So 1i is your answer.
How did we get the first -1 though? 'Cause I thought it was just like I squared.
It's this coefficient. I'm doing -1 times -1 times -1, just like what did you do here?
Okay.
You did 2 times 2 times 2 in the front. And then, like an afterthought, like you can separate those two ideas, right? The 2 cubed part and the a cubed part, right? So I'm going to do that here because this is a -1. Here, do you want me to separate it like that? -1 to the 15 and I to the 15, like I separated that. Okay. Let's talk about this first. So the 2, is it included in the repetition? Yes. So really you can think about, I'm going to do this a long way. You don't have to. You can think about doing a 2 getting cubed and an I getting cubed. You can think about it, separate it like that if you really want. Times. Oh, there's a negative coefficient on this. So you can think about that like a -1 getting repeated 9 times and an I repeating 9 times. If you like to separate your coefficient repetition and your variable repetition. Okay, let's talk about this number and this number. What do we get here? 8 times -1 on that. So can we just write -8? Is that good? I. What's the rule with the exponents when you multiply like that? Add them. Okay, so know your rules. Let's get some I squareds out of that. And this one's going to be a perfect, right? 6. What happens if you times -1 over and over 6 times? +1. +1 times the -8 though.
-8.
-8, sad answer.
No eyes.
No I's in this one. Okay, do you remember breaking down radicals? Can I give you an example of your grade 10?
Like
This is what you did in grade 10 and 11.
root 5.
Root 9 and root 5 is root 45, and then the root 9 is 3. Remember that breakdown?
Terrible.
Okay. Okay, ready? So I'm going to break this down
10 and 10.
into the square root of 100 and the square root of negative 1.
Oh, okay.
Does that make the square root of negative 100?
That's cool.
Yeah? Okay. What could I call the square root of 100 instead? 10. What could I call the square root of negative 1 instead?
Of an I.
Whoops, I crossed.
And
Okay, but the next example doesn't work because the square root of 8 isn't perfect. But
we know things.
can we do work? Is there a squareable number to break this down with?
4 and
4. 4 and 2. So the root of 4, the root of 2, and
negative.
the root of negative 1. That all together would be negative 8 inside there, right? Then what do we know? The square root of 4 we know.
2.
So 2, leave root 2.
What? It's the root of 2. It's 1.4. Oh. Oh, sorry.
It's not good. It's not perfect.
Okay.
We cannot square root 2. Okay. So you're in advanced math. So this is going to be more of your level. You're not going to square something. You're going to cube it. So you ready? We'll make it a little longer. I'm going to challenge you a little more.
I'm challenged. 9, 27. Does it work like that?
No.
Okay.
No. What do you do in math when you times 3 things?
2.
Get just times 2 of them right now, okay? Just work on 2 of them. So this is a FOIL. So we're going to go 9. Are you okay if I do O's and I's?
Yeah.
This is 15 I's and 15 I's. So 30 I's plus 25 I's squareds. Okay, what do we want to do? You got 2 options here. We could times this trinomial by the binomial, or as is, or do you want to like work with this I squared before the timesing? And it doesn't matter.
Work with the I squared before.
I squared before. Okay, so what is I squared? Negative 1. So now I can do this. I can go with the 9 minus 25, right? Do we like that? Because this would be negative 25. Okay, what is 9 subtract 25?
Negative.
16. Right? Okay. Now, times. Oh man. Negative 48. I'm just going to FOIL. I'm not going to do my things here. Minus 80 I's out. Plus 90 I's in.
Are you gonna foil it or like factor? Or I guess not for foiling.
No.
Never mind.
We're doing the opposite thing of factoring. We're expanding, right? Foiling and factoring would be the opposite things. Okay, I'm gonna do some work here. I'm gonna collect that. So we're gonna write 10I at the end of this thing. And I'm gonna think about this as a negative 1. So let's go a subtract 150 value. So we got that, subtract 150, okay? There we go. So try to always break things down until you get to numbers and I's, but you can't go further after that. Okay, and then this is the last question. I'm just rewriting it because I ran out of room. Okay, do you remember a trick that you did in grade 11 called rationalize the denominator? Which in grade 11,
Conjugate?
way ahead of me. In grade 11, you learned it because you didn't want the radical in your denominator anymore, okay? So this is going to transfer to I don't want i's in my denominator. Okay, so Aiden already spilled the beans. The trick is the conjugate. Okay, so I'm going to think about a conjugate to that. Do you remember what conjugating is?
Same thing, opposite.
Same thing, opposite sign, but guess what? If you do it to the bottom, you better do it to the top. Okay, so binomials, you're going to have to FOIL this thing out. Hey, what's the little secret to conjugating, foiling?
Flip.
Forget that, just those two. Okay? So good. And you always remember there's a minus, right? No matter what. Because these signs are always opposite that you've created. So there's always a minus. Okay? Go for it. On your own. I'm going to be like an info commercial, but wait. There's more. Did we all get to this level? What if I said this question had to be written in simplest form? Is there anything more you could do with this to knock it down somehow? What'd you say? Reducing. Is this divisible by 20? Can we reduce this as well? Okay, what are we going to do? Divide by 2. So 1 plus 7i over 10. We could just reducing it.